Hello and welcome everybody. Thank you for joining this webinar on UltraGLOSS. I really appreciate the time that you're taking out of your day to be able to sit in and learn about the UltraGLOSS product from Asiga. Let me go ahead and share my screen. All right, and you guys should be able to see my screen, and so hopefully all looks good. Let me just move this over. Fantastic. All right. So today's webinar, it's titled, Are You Glossin? It is a play off of Asiga UltraGLOSS, the name of our new technology that we released at IDS this last year. And this presentation, it has three main objectives. The three main objectives is we're going to learn what UltraGLOSS is, we're going to learn what it is used for, and then we're going to learn how do we use it. How do I harness this technology in my dental laboratory to make myself successful, or what can I use it for? And so let's knock this first line off the checklist of learning objectives of what is UltraGLOSS. So UltraGLOSS itself, people actually thought it was a material that we released. It's actually not a material, it is a build tray. So the actual build tray itself is what creates this gloss effect. So UltraGLOSS is a build tray that produces polished prosthetics naturally during the printing process. And all it is just simply the resin build tray. At Asiga, really in the last, we've always tried our best to make the end users' lives a lot easier, make your life a lot easier for using our technology. And so we've made excellent printers that are accurate and predictable. We've made software that's really simple and easy to use. And then we're looking at ways, how can we make the lives of a dental lab technician even easier yet? What technologies can we implement? And so we've actually worked on this UltraGLOSS project for quite a few years now, and we developed something similar to it in the audiology sector. And then we found a fitment in dental, and that's where we launched the UltraGLOSS resin trays. And so it is simply just a resin tray that you'll print with that will create this polishing effect. So I do have some technical information on the UltraGLOSS build trays. And so the first question that we get pretty commonly or quite often is, what printers are compatible with the UltraGLOSS resin trays? And so the UltraGLOSS resin trays, it's compatible with the Asiga Max series machine and the Pro 4K series machines. If you have a predecessor machine like the Pico 2 or Pro 2 machine, unfortunately the UltraGLOSS trays are not available for those systems, but they are available for the Max series machines and the Pro 4K series machines. The build tray capacities is the next question that we get pretty commonly. This is just technical information on it. The Max comes in a 1 liter usage capacity, and the Pro 4K comes in a 2 liter usage capacity. Resin compatibility is a third question we get pretty regularly. And what resins are compatible with these UltraGLOSS trays? So remember, these UltraGLOSS trays, they provide a polished prosthetic during the printing process. So we wanted to find a way to make lives easier. And we found a way for the printer to actually do the polishing for you. I believe there will be here shortly a poll that will come up asking, who does not like polishing their splints afterwards, or how much time do they splint? Actually, yes. So here it comes in. We have a poll here that says, do you find polishing the splints and mouth guards time consuming and difficult? And I think the answer for this for everybody is it's not so much difficult, but super time consuming. And getting it right is pretty crucial to be able to get that truly perfectly transparent prosthetic. And so with the UltraGLOSS trays, they're actually compatible with just about any clear material. And so let's say if you wanted to produce your splints with key splint soft, key splint hard, key splint soft clear, key splint hard clear, or even like, for example, the Whitmix Fair Splint OS, those materials are all compatible with the UltraGLOSS trays to be able to print and have a truly clear splint. I have a couple of photos here coming up that really show how transparent of a splint you can get when you use the UltraGLOSS resin tray. What about other resins out there? We just highlighted the Keystone Materials and Whitmix's Fair Splint OS. What about what if I wanted to produce a tri-indenture that is completely transparent, or not completely transparent, but polished? We can actually do that. So for example, if you were to print with the UltraGLOSS resin tray with the Denta Tri-in material from Asiga, your actual tri-indenture will be polished. And so it'll already have that polished high gloss effect, and it looks actually quite good. What about model material? Now, this is a material that you'd want to stay and steer away from using the UltraGLOSS technology for. Unless you just want a super shiny model, you could use it for that. But we actually found that there's no positive impact of using an UltraGLOSS tray with model material. Really, you should use the UltraGLOSS trays for like final prosthetic parts, for example. Another application that would be good would be, for example, surgical guide resins. I know when surgical guides first came out, everybody wanted the most transparent, perfectly clear surgical guide available. And then that kind of tapered off because they just needed to punch a hole in somebody's jaw. And that was the whole objective of a surgical guide. And they didn't really care so much if it was transparent or not, at least today now. But now you can actually produce an accurate surgical guide that is almost perfectly transparent if you have a doctor that still wants that transparent, clear surgical guide.
So Cory, you have the results, and if you want to hear what the results are.
Yeah, that'd be great.
So 90% of our attendees feel that polishing is time-consuming and difficult. And 10% feel it isn't. So 90%, that's an awful lot.
So for 90% of our population and user base, we literally just solved one of your, I guess, a major headache in the dental laboratory of being able to polish and finish splints for you. Thank you for sharing that. That's actually really insightful.
We have a question, and I don't know if you want to answer this now, but Nick wants to know if we can use this with denture tooth resin.
So that's a great question. I have not tried it with denture tooth resin at this point in time. There are some materials that if a denture, or if any resin has a glass filler in it or like a ceramic filler in it of some sort, then that material does not actually polish that well using the UltraGLOSS trays. And so if you're to print, for example, like our denture base resin from Asiga, it has some filler in it, and it doesn't give it that perfectly polished effect. You could try it with other denture materials that are out there on the market, and some may polish really well and some may not have the polishing effect. It all depends on really the chemistry and if it has a lot of filler in it. I have tried with the Dentsply denture base resin and denture tooth resin. It comes out really high glossed and polished. However, because the post-processing is very technique sensitive with that material where you actually have to use a little brush to scrub clean the parts, it does eliminate the polish effect. And so because of that workflow, it doesn't really work that suitable for the Dentsply resin. It will be more, I guess, polished than what it would be if you didn't use the high UltraGLOSS tray. So there is some benefit to it, but you may find that with like the different washing techniques with different resins, it may not yield the best results that you're looking for. But that actually brings up my next topic of what dental applications of use can we use this for. And so we see the UltraGLOSS trays being used for splints, night guards, occlusal guards, surgical guides, denture tri-ins or that material that doesn't have filler in it. Really any material you want to have a gloss effect, it will work on. I tried some custom impression trays. I just wanted them to have a gloss feature to it, and they came out perfectly polished. So there's other applications that I think we'll see coming down the pipeline where we'll do more research on and printing it, especially I think in the denture-based denture tooth resin application. There's a huge market for that. It's just finding the right material that responds properly with the tray is the process that we're going through now. And then the next bit of technical information, which is really a tip. If you're going to use the UltraGLOSS tray, please make sure that you're on the latest software and firmware from Asiga. And so you need to be on Composer 1.3.9, and I'll show you why here in a little bit. We're going to do a hands-on demonstration. And then we also need to make sure that they're using the firmware, which was released on May 16th of 2023 on your printer, and this will allow and accept the UltraGLOSS tray into the system. So it's important that you have both of those aspects applied to your hardware. If you are a new user of Asiga, or you don't have an Asiga machine yet and you're looking to buy, that should already come installed with the latest software and firmware ready to go. But you may want to double check just to make sure. All right. Let's see if I can get it to go on to the next. There we go. So how does the UltraGLOSS tray really work? And so this is a question that we get quite a bit. And so I pulled this slide from our general presentation just on what 3D printing is. And so the UltraGLOSS printing process is actually identical to your existing process. You just use a different tray. And so you'll have a build platform that's going to move down into your liquid resin vat with your material of choice, like, for example, key splint soft or key splint hard. And you'll have your DLP projector below, and it's going to project the image, and it's going to cure it layer after layer after layer. However, with the UltraGLOSS tray, the way that the tray is designed, it's actually going to soften the exterior pixels that are being projected. And when I say soften, not as in make it like malleable or soft by touch, but as in the optical image, it actually softens the pixels that are being projected, causing the outer edge of the layer being created to become polished naturally. And so it just has this natural polishing effect while it's creating the layer. And it will do this layer after layer after layer until the object is completed and you have your polished part. When you're done with the printing process, there's a post-processing guide that you need to follow. And so just for post-processing an UltraGLOSS print, the number one thing that you need to do as an end user is to stick to the material manufacturer's instructions for use. And so each resin bottle, whether you purchase it from Keystone or Whitmix, it's going to have an instructions for use with that bottle of resin. If it's not with a bottle of resin, they may have a QR code that will point you to the website that will show you how to handle that material. You need to follow that because when you're printing with the UltraGLOSS tray, your actual process really doesn't change. All it is just a resin tray that you'll be changing out. I actually have a tray right here. This is simply what it looks like. It's just a resin tray. And so when you're changing your process in printing with an UltraGLOSS tray, the post-processing requirements will stay the same. And so most importantly, stick with the material manufacturer's instructions for use. Your post-print washing process is going to be identical to what you did before. Most materials will recommend that you use an ultrasonic cleaner or some sort of wash bath for, let's say, for example, 5 minutes. The instructions for use will list that actual time limit, and you want to stick to that. A little tip that, and I'll cover these tips again, but when you're doing your post-print wash process for an UltraGLOSS printed part, make sure that you wash the part and you stick to that time limit. If you were to extend the time that's being washed, you can actually degrade the part and have a less polished or glossed finish after you do your wash. So if the instructions for you say wash it for 5 minutes, stick to that 5-minute protocol. Do not extend it because it can actually degrade that surface quality and make it look less polished than what it would if you were to stick to that time limit. And then same for the post curing process. And so after you wash it, you will need to go through the curing process. You're going to follow the IFU, stick to the amount of time in the proper curing unit for that printed prosthetic or that printed resin, and you will be able to achieve the proper cure that you need to. So the beautiful thing about the UltraGLOSS resin tray is that you print, you wash, you cure, and then you may have to do a little bit of finishing, but you can actually almost completely eliminate the polishing process. All right, so let's go ahead and view this case study. So we actually had a case study written by Dr. Kaysen Samana. He's actually based in Australia, close to where our head office is. And so he actually went through and did a case study for a patient using the UltraGLOSS resin tray. All right, so we just had a question come through. I'm just gonna answer it real quick. It says, how do you deal with areas where supports are? We're actually gonna cover that here in a few minutes. That's a really good question. All right, So let's take a look at this case study. So this case study, there's a 34-year-old female, and she wanted to improve her smile along with with creating slightly sharper upper canines, and she also has a history of bruxism. And so the treatment plan for this patient is they're going to do a complete digital smile redesign, and they planned out 10 porcelain veneers and 2 resin veneers on her upper anterior teeth. And along with that, because of her history of bruxism and the increased length of her new teeth on the, it actually increased the lateral and excursive forces, a occlusal guard was needed as well. And so not only did they go ahead and plan out her new smile, they also thought about in the future, what will she need next? An occlusal guard was needed. And so for this process, the doctor used for the splint design, he used the 3Shape Automate application. He printed on an Asiga Max UV. He used the UltraGLOSS 1 liter build tray and the Keystone Key Splint soft resin. And the results was a 3D printed occlusal guard with minimal adjustments and 0 polishing needed. I do have a few photos here so we can really take a look at how good the results are. I think this is what everybody's kind of excited about, is learning how the actual part looks like when it's finished and delivered to the patient or delivered to your doctor. So this was actually the print on the build platform. So this goes to the question we had just a few minutes ago. What do we do for the supports? And so we can see that this splint was printed vertically, but we can see that there are some supports on the posterior region of that splint. For that, you would actually remove that simply with a fiber wheel, or you can use one of your grinding burrs, for example, just to eliminate it, and then use a fiber wheel just to fine remove and just sand it down where those support parts are. If you want that posterior region, just where those supports are, to have a gloss effect or polish effect, then you can hit it real quick with a high shine on a lathe. But honestly, it's in the posterior region. You realistically probably wouldn't even need to polish it. It's not going to make a difference for where the patient and where the doctor will actually see the transparent effect. So this is actually the results of the splint in the patient's oral cavity. Now this was printed, washed, cured. They did remove the posterior nubs. They used a fiber wheel for it, but there was no extra polishing done to the splint. Look how transparent it is. You can see the layer lines still. So this was printed in 50 micron layers. You can still see the layer lines. If you wanted to remove the layer lines itself completely, then the next step would be to use your lathe with a high shine, and that would remove and help remove those layer lines. If you're not so disturbed by the layer lines itself, then you can simply deliver as is after you do your curing process. Here's another photo from a side view. Really transparent. Looks fantastic. All right. So that just, we're able to go through and discuss what the UltraGLOSS build tray is, what it does, how it works. We discussed a little bit about the materials that it works for, and we just reviewed a case study where it was applied. You can see firsthand the benefits to it, reducing the amount of time that anybody would need to actually polish the splint itself. All right, let's go ahead. I'm going to pull up my Composer software and a couple resources, and let's go through the nesting techniques that we recommend when utilizing the UltraGLOSS build tray. We did have a question that came in. It says, do splints need to be oriented with the posterior region attached to the build tray? Is this just to minimize support scarring? That actually, you answered your own question. Do you need to support them in the posterior region? Technically, no. But for the printed prosthetics to be as effective as possible for the polishing aspect or the UltraGLOSS effect, it is best to print it as vertical as possible with as little supports, minimizing the support contact points to give it the most polished aspect. Let me go ahead and let's see, we answered that live. Let me go ahead and just move this over. I want to show everybody, before we jump into Composer, I want to show everybody that we have this technical resource guide, and you can view all the technical information you need on how to use your build tray on our website. So we have a support site. It's support.asiga.com. When you're on our support site, you can simply select on the build tray. So for example, I want to view the build trays. I want to view the information about the build trays from Asiga. So I selected on the build tray option. And now if I select on this drop-down menu, I can view the different options I have. So I can view information about the different types of trays from Asiga, whether you want to learn information about the general manufacturing trays, the UltraGLOSS trays, and the low force trays. We have information on that. We have information on how to use UltraGLOSS by Asiga. We're going to click on that. We also have information about maintaining your build tray, what the little holes on the corners of the trays are on the Pro 4K, and what a suction cup effect is. We're actually just going to simply select on how to use UltraGLOSS. So let's review this guide before we jump into Composer. All right. So UltraGLOSS, it just covers how, or this FAQ covers how to use the UltraGLOSS tray, what it is, what it does for you. Talks about third-party materials. It's important to always follow the manufacturer's IFU. The applications that it would be good for in dental. So inside dental, we recommend for night guards and occlusal splints. You can also look at it for surgical guides and even other applications that needs a polished effect in the final prosthetic. Shows the printer compatibility, which we've also covered. Now it gets into the nitty-gritty of orientation. So this is what we recommend following for nesting and using and printing your splints using an UltraGLOSS tray inside of the Asiga Composer software. So we recommend printing it vertical with a 10-degree inclination. And then we have 4 different support structures. And so we have a planar cut. So for example, in your CAD software, let's say if you're using 3Shape, you can add a planar cut to the posterior region and then literally place the splint directly to the build platform on that planar cut. The next option is to perform a CAD design where you add in a little supporting block that is non-crucial to the STL, and then you can export it all as one. This may use you may need to use like a third-party software such as 3D Builder or Mesh Mixer for that. This was my favorite, which is the Composer option 1. That's where I simply will just drop the splint down through the bottom of the build platform in the nesting software, and it'll automatically cut off that area. And I'll explain this process. This is the one that I'm going to show today live. This is one that I do almost all my prints with. And then we have the fourth option, which is literally applying just general supports and sprues to the prosthetic. This can be the easiest way without any air, but you may have areas of support that you didn't want supports. That's going to leave some natural scarring that you will have to hand polish away after. All right. Setting up the UltraGLOSS, we're going to cover this here in a second, but if you ever wanted to set up a print using the UltraGLOSS tray, this guides you through it and what to do in Composer, and then also how to set up your printer, and it talks about the post-washing and post-curing process. A little note, if you were to print a part in different layer thicknesses, you may yield different results. A thinner layer thickness, we recommend 50 micron layers for all of our UltraGLOSS prints. You're going to get more of a polish effect versus if you're printing 100 micron layers. It'll still be polished, but it won't have as transparent of an effect. And also, different materials will yield different results due to their chemistries. Some resins may yellow after the printing process and curing process. Some may have a little bit of a green tint, and some of them may have a bluish tint. And so these tints are part of the chemistry and the photo initiators that are breaking down in the post-curing process. All right. This resource is for you to keep and to use anytime you're printing with the UltraGLOSS tray. Let's go and let's dive into it. Let's see a live demonstration of how to nest a part using or for the UltraGLOSS tray in Asiga Composer. All right. Just going to open up my Composer software. Maybe. Let me see. Give me 1 second. It's opening up on a third screen. I just need to transition it over. While I'm transitioning this, if anybody has any questions up to this point, feel free to throw them in, and then we'll get the Composer software opened up. Right. Let's see if we can get that.
We have a couple of questions. Cory,
Okay.
I don't know if you want me to read them out to you while you're doing this.
Yeah, go ahead and read them out.
Okay, the first is from Kojo, and he wants to know is, do splints need to be oriented with the posterior region attached to the build tray? Is this just to minimize support scarring?
So it is, let me see here. Do splints need to be oriented? Oh, so that's to minimize the support scarring. Absolutely. And that ultimately will also give a more polished effect as well.
And Tanya wants to know, will these trays create a glossy finish on denture resins?
They will create a glossy finish on denture resins, yes, but it may not, depending on the resin itself, it may not give you exactly what you're looking for. For printing with surgical guide resin, or not surgical, with denture resins, depending on the resin itself, it may yield better results versus some resins. It may not be beneficial at all. So I've found with materials that have a filler composite in it, for example, like there's quite a few materials out now that, like for permanent crown materials that have glass in them or ceramics of some sort in them. The gloss effect, when the light's trying to pass through the tray, it doesn't really give a true gloss effect to the part, and so it doesn't really. It's not going to give you any sort of added benefit. Versus if you were to print with the a material that doesn't have a glass filler in it, you'll actually get better results for it. It will give a more natural gloss effect during the printing process itself. That's a good question. I think the holy grail for using the UltraGLOSS trays is ultimately really using the it would be for denture resins, so denture-based, denture tooth resins, and then for splints. I think those are the three winning applications where utilizing the UltraGLOSS tray, you're going to get the biggest impact from. We developed the trays ultimately around printing splints and being able to print splints without polishing. And then we found that there's other applications that this may be beneficial for. And then it's just determining which application that will actually be good for. That's what we're trying to work out today. Let me set this up real quick. I think it may be working now. Let me just set this. Reason my computer thinks that there's 3 screens when there's actually only 2 screens, and it's wanting to put my Composer software on the middle screen, which doesn't exist. So let me see if I can get this to populate again real quick.
While you're doing that, Cory, I'll just let everybody know that we have what's coming up next on Zahn Academy tomorrow at 2 p.m. Same time, we have Tim Torbenson coming back. He's the president of Evo 820, and we're going to be talking about getting to know Evo 820's EQMS system. So that's tomorrow at 2, and registration is still open for that one. That one's pretty interesting.
Okay.
Clients.
I just got it. Sorry to cut you off there.
Good.
All right, let me share my screen again. Okay. I love doing live webinar presentations because there's always something that goes wrong, and it's usually more extreme for people that are in like technology companies where we produce like cutting edge technology, but then as soon as we get in front of Zoom, we just struggle so bad. And so thanks for everybody bearing through while I got that sorted. So everybody should be able to see my Asiga Composer software now. And so for setting up your print for the UltraGLOSS tray, the very first thing that you're going to do is you're going to create a new build. And so we're going to select new, and we're going to find our printer. My Asiga Max here at Asiga America on the show floor is called Showboat. So I'm going to choose Showboat, and then I'm going to choose the material I want to print with. So let's see here. I should have some key splint soft. So I'm going to select on the latest key splint material profile. And then I'm going to choose what layer thickness I want to print in. So by default, you have 3 layer thicknesses to choose from for key splint soft: 50, 75, or 100 micron layers. When you're printing with the UltraGLOSS tray, you'll yield better results by printing with a 50 micron layer thickness versus a 100 micron layer thickness. So I'm going to choose 50 microns. And then I'm going to choose my build tray. And so we have a universal build tray, which is just our general purpose tray. We have our low force tray, which is meant for like flexible applications, such as like gingiva masks or very delicate parts. So let's say if you're printing RPD frames, we'd recommend a low force tray. And then we have our UltraGLOSS tray. So I'm going to go ahead and choose UltraGLOSS, and then I'm going to select OK. If for whatever reason, if you're ever confused on which build tray you have and which one you need, you can simply select on this link here, and it will take you to where our build trays are and how to understand which one you need to use. So I'm going to select OK, and we're going to create our build. And so I'm going to go ahead and I'm going to navigate and find my parts. All right. See if I can find it. I have a splint that I designed for my technical manager here at Asiga America, Ken Wong. Let's go ahead and import this guy, and let's set it up for printing. So we can see that my STL file does not have any sort of CAD blocks generated on it, and it does not have a planar cut surface to it either. So I'm simply going to use the third option that was in that guide, where I'm going to drop the part through the actual build platform. It's going to cut off two areas that are really not beneficial to the prosthetic, and it will attach directly to the build platform. And so before I do this, I want to review the actual part from a side perspective. I'm going to try to make it as close to 90 degrees or straight vertical as possible. And then if you remember in the guide, we're going to go and rotate it 10 degrees. And so if you see my mouse, it has a degrees around X axis. So I can see exactly how much I'm rotating it. I'm going to get it close to 10 degrees. It doesn't need to be 10 degrees perfectly, but just close to. And then I'm simply going to look at it from a front perspective or back perspective, either way. I'm going to left click and hold on the part, and I'm simply just going to drop it down until that posterior region of my splint, the heels are going to be cut off. Now, this part of my design, it's not crucial. There's really no form or function of this part of my splint. And so by me cutting this off, I'm not causing any harm to the actual prosthetic. I do design my splints so they are a little bit thicker on the posterior region, especially on this posterior heel, so that I can attach it to the build platform and not worry about taking away any part. And I also want to be careful that I do not have my part actually cut off where it may be engaging in the existing dentition. So this was option number 3 for the nesting process. This is how I do all of my splints. Let me go ahead and show you the 4th option, which is where you'd actually use the supports. These last 2 options do not require any special like CAD design or CAD editing to do. So if you're using an outsourced service for your design, you don't have to worry about them doing anything specific. You can really have the most freedom with these 2 methods. Let me go ahead and clone this splint. So I'm going to clone it. And then let me look at it from a back perspective. I'm going to lift this one up. And let's go through the supporting and spurring technique for this splint here. So if I wanted to add supports to this structure, I'm simply going to go up to the top left. I'm going to select on Generate Supports. Now, I'm going to do it just for this part here alone, so I'm going to select on Selected. And then I'm simply just going to go ahead and select Apply. Now, this is going to show all the supports. I'm not actually going to use this. This is quite a few supports, and really in this region, it's really not necessary. I'm going to undo. A more advanced way of adding supports is I'm going to use my clipping view. So on the right-hand side of the screen, I have a clipping view, and then I can find my first contact point, my island points for my part. So I can see them here. I'm now going to select on Sprue. And I'm going to change these to 4mm sprues. And I'm simply just going to apply 2 sprues to my part. And now if I was to look at it, I could actually print my splint just with those 2 sprues. If you felt like you needed more sprues or more supports, then I could come back in. Another little trick is you can use the tallest support function in our software. So I can do, for example, tallest support, and I can do 10mm. And I can tell it to apply supports from the build platform in 10 millimeters taller, or 10 millimeters tall, and then anything beyond that on the actual structure is going to ignore. And so I was able to prevent the software from applying any sort of extra supports in a region that it may not be necessary. Now, I've printed a few hundred splints, and so I know what to look for a failed print and not a failed print. This part here, it's awfully close to having an unsupported island right here in this region. If you were concerned on if you have enough supports to be able to print this prosthetic, if we were to look at it from an underside point of view, and if I was to scroll up through the slices, I'm looking for an unsupported island. And so if that region was unsupported, it would pop up not connected to anywhere else. And so this actually looks really good. I'm not going to need to worry about having an unsupported island. But you can use this clipping view to find an unsupported structure where maybe you need to add in just a single support, for example. All right, I'm going to close out the supports. I'm going to undo. We have our 2 splints. We can see that we still have quite a bit of real estate on the build platform of the Max, just for kicks and giggles. Let's go ahead and switch this as if we were printing on the Pro 4K. So my Pro 4K is called Scarface. Just so you can see the overall sheer build volume that you have with the Pro 4K. So we can see there's quite a bit of real estate. We can put anywhere. I think I've had the most, I think it was like 24 or 26 splints on a Pro 4K printing at once. All right, so from here, we're going to send the print job to the printer. So the build wizard will give us general information about the job itself, about the material, what we're printing. I'm going to turn fast print mode on and separation detection. And then because I do have some parts that have supports, I do want to have a shadow for supported parts only, and I prefer a 0.3 millimeter thick base plate. So that'll just be a base plate underneath this part. And we'll simply select continue, next. Let's name this UltraGLOSS splints, and we'll send the job. I'm going to go and cancel. We don't need to send this job because we're not going to print this. This print job for these two splints, it says it's going to take 3 hours and 19 minutes. That would be the same if we had a full build platform of splints. So let's go ahead and let me just delete that guy out. And let's build a platform of splints. And if we were to print this full build platform of splints, it's still only going to take the 3 hours and 19 minutes, which is just fantastic. If we want to see how many parts we have selected, let's see how many parts are on that build platform. So we have exactly 24 splints on here. We could easily print that in 3 hours. And the beautiful thing about it is when it's done, you're going to wash it, you're going to cure it, maybe have to finish off those supports a little bit, but your prints are already polished, your splints are already ready to be delivered to your doctor, and there's very minimal, almost zero post-polishing needed for that. All right, so let's go ahead, and that covers the hands-on aspect for the Composer software. Remember, we have this awesome guide on our website that covers this for you, so you can actually view exactly what I just did step by step and give you insight on how to be able to accomplish this with ease. All right, let's jump back to our presentation. Let me pull that up real quick. All right, so we have a couple tips for using the UltraGLOSS build trays. First one is always follow the material manufacturer's instructions for use. Remember, the UltraGLOSS is simply a build tray, not a material, and you can use just about any clear material in this build tray and yield a polished part. If you reach out to your Zahn rep, they'll be able to hook you up with a key splint, soft materials or key guide, or for example, the Whitmix VeriSplint or VeriGuide materials for printing with the UltraGLOSS trays. Another tip is that you want to orient to minimize support. So it's funny that we had that question because literally I think half of your verbiage is in this line of orient to minimize supports. We want to print in 50 micron layers for the highest clarity, or to be able to achieve the highest clarity. We want to try to handle as little as possible. And what that means is that the longer you wash a part, or the longer you touch a part before it's been cured or washed, you will actually dull that glossed or polished finish. And then, of course, do not overwash because it can also naturally pit the part as well. I have a quick video that shows the UltraGLOSS process. Let's go ahead and give this a little look. It's actually more like a highlight video. Awesome. So let's go ahead and let's turn it over to some more Q&A. All right.
So the next question is, can we automatically sprue only the heels of the night guard without adding supports to the center? And I think you kind of answered that one already.
Yeah, so you can sprue the heels of the night guard without adding supports to the center. Yes, there's no like automatic feature that will do it for you. So you will have to manually move it and perform that. So there's a little bit of manual handling, but yes, you can absolutely print with the heels down. The next question that we got in, I have the question thing pulled up, so I'll just read it.
Oh, you do? Okay, great.
We tested as if you touch the object under the curing process, the object doesn't get glossy at all after finishing curing process. We tested as if you touch the object under the curing process, the object doesn't. I don't think I understand the question completely. But the part will still, like if you manipulate the part a lot before washing and before curing, it will become less glossy than it would if you try to handle it as little as possible. And I mean, like with your hands and your gloves, if you were to sit there and handle the part before you actually wash it and cure it, the glossing effect will not be as shine. Next question is will it give a shine to Lucitone printed base resin, or the denture base resin from Lucitone? I did print a denture base with the UltraGLOSS tray. Because of the post-washing process that is required for the Lucitone material, you actually have to use a brush to scrub it. That scrubbing effect with the brush actually removes the polish effect. It gives it more of a matte finish. It was shinier than what it would be if you didn't use the UltraGLOSS tray and use a standard tray, but you still will have to do some polishing with it. So it wasn't a perfect solution for that material. However, chemistries are continuing to evolve. You never know, maybe there'll be a chemistry where you don't have to do the scrubbing aspect, and then it would work perfectly. The next question is, do we use the auto flash or Asiga light flash after washing? So this question, actually, the answer for it depends on the instructions for use. And so the resin has requirements for what washing process and what curing unit and curing process you should follow. You'll want to follow those instructions as prescribed in the IFU to be able to properly post-cure it. Most resins are validated using the NK Optics Auto Flash. But there are others out there that are available to use that may meet the IFU. And then how do you recommend removing excess resin from the intaglio surface of a splint? So really the best way is to continue to wash in alcohol. If you performed your alcohol bath and there's still resin in there, I'd place the intaglio surface so it's facing down in the alcohol bath to allow the resin to naturally drain out. If it still looks like there's liquid resin in there, go ahead and give it another second wash according to the instructions for use to make sure that it's not potentially violating anything that could change the biocompatibility of the printed part. But I found that some resins, depending on how sticky they are, you'll do like a 5-minute wash, and then if it still looks like it has resin in it, then I'll put it back in for maybe another 1-minute alcohol bath to see if it will clean that out. And then if it does clean it out, I'll let it air dry for about 30 minutes and then post-cure it. Yeah. Those are all really good questions.
Yes, it seems like we answered all of the questions. Cory, any last tips that you want to give the audience before I close out?
I think the biggest tips or takeaways for the using the UltraGLOSS trays would ultimately be to make sure that read the instructions for use for the resin. Make sure that you print in a 50 micron layer to yield the best results, and then really those are the final thing is make sure that your printer software and firmware is up to date to make sure that you can utilize the latest and greatest from Asiga, especially the UltraGLOSS trays.